session 13, the atom. Speed physics. Draw and label a diagram of an atom. That would be the nucleus in the middle, made of protons and neutrons, and it would be surrounded by electrons in orbiting shells. What is the typical size of an atom? Well, it's about 1 times 10 to the minus 10 meters. A small molecule, well, what if you had carbon dioxide, something like that? That would be 3 long, so you could just say 3 times 10 to the minus 10. What does atomic number mean? It's the number of protons that it's got. What does mass number mean? That's the number of protons added to the number of neutrons. That's the total mass number of the atom. What does this tell us? It tells us everything we need to know about the atom. The atomic number, not only does it tell us how many protons there are, but it tells us how many electrons there are as well. What is an isotope? It's something with the same number of protons but a different number of neutrons. Give an example. You can have carbon 12 or you can have carbon 13. Same number of protons but a different number of neutrons. Remember, this top number here, that's the number of protons plus neutrons added together. That bottom number there is just the number of protons. So if you take the bottom number away from the top number, that tells you how many neutrons there are. For example, there's 7 neutrons here, whereas in this one there's only 6 neutrons. What are the relative masses and relative electric charges of protons, neutrons, electrons and positrons? Well, the mass of a proton is 1, mass of a neutron is 1, mass of an electron is negligible, which means so small you can just about forget about it, and mass of a positron is also negligible. The charge per proton is per positive 1, neutrons are neutral, electrons are -1 and positrons are +1. If an atom has 13 protons, 14 neutrons and 13 electrons, is it neutral and why? Well, protons have got a positive charge, electrons have got a negative charge. Neutrons are neutral, so you can forget about them. So it's got 13 pluses and 13 minuses. Is it neutral? Yes. Why? It's got the same number of positive charges and the same number of negative charges. In an atom, the electrons orbit the nucleus at different set distances from the nucleus. What does this mean? So just say, there's your nucleus there. Got some electrons in this shell at that distance. You got some electrons in this shell at that distance. Some electrons in this shell at that distance, etc. What happens to an electron in an orbit when it gains energy? Right, it could jump from a lower energy shell up to a higher energy shell. Bohr used quantum theory to explain if an electron absorbs electromagnetic radiation with the right amount of energy, it can jump into a higher orbit shell. What happens to an electron in an orbit when it loses energy? It will drop back down to a lower energy shell. Explain how atoms may form positive ions. They lose electrons. So just say you've got an electron orbiting around here. Some gamma comes along and hits it, knocks the electron off. Gamma is only weakly ionizing, as shown by my animation. This atom now gains a positive charge because it's got one less negative charge. So if, like before, if it had 13 protons and 13 electrons, now it's only got 12 electrons. So 13 positives and 12 negatives, that leaves an extra 1 positive. Describe how and why the atomic model has changed over time. Again, I've got a nice little video on this on my channel. The plum pudding model what they say is that the whole thing is generally positive, and then you've got some negative charges in localized places. And then Rutherford came along with his alpha scattering experiment, and he realized that the mass of an atom is kept in a central location, which they call the nucleus. Again, I've got a nice big long video on Rutherford's alpha scattering experiment. Most of the alpha came straight through. Some of the alpha particles got deflected, and every so often one of the particles would bounce back, and the only reason it would bounce back is if it was on a head-on collision with something very dense. So they decided that most of an atom is empty space. They knew that the alpha particles were positive, so when it got deflected, the positive thing must have came close to something else that was positive, and when it came back in the opposite direction to what it had came, back to the direction where it came, that must have been because it hit something very dense and also positive. The diagram shows an atom of carbon. A, B and C are 3 different particles. Name them. Right, well, we know that the number of protons is the same as the number of electrons. So I don't know yet whether A or B is the protons until I count how many electrons there are. 1, 2, 3, 4, 5, 6. So we know that particle C are the electrons, and we know there's 6 of them. So that must mean there has to be 6 protons. 1, 2, 3, 4, 5, 6. So there's 6 white ones. I'll just count the black ones. 1, 2, 3, 4, 5. Oh, there's 6 of them as well. That's a bad question. So basically, A or B doesn't really matter. You can say A is protons, or you can say B is protons. If I say that A is protons, then B will be neutrons. What they should have done is they should have done 1 extra neutron. So then B would definitely be the darker circles. Beryllium-9 is a stable isotope of beryllium. State the meaning of the term stable. It means it won't break up at any time. It'll just stay as it is. Beryllium-9 has an atomic number of 4 and a mass number of 9. The nucleus of this isotope can be described using this symbol. Complete the sentence by putting a cross in the box next to your answer. The number of neutrons in this nucleus is, well, remember the number of neutrons, you take the bottom number away from the top number. So that's 5. Which of these symbols describes the nucleus of a different isotope of beryllium? Put a cross in the box next to your answer. Well, it would have to have 4 on the bottom, and if it's a different isotope, you would have to have a different number on the top. So it's A. And there we are. Thank you very much. Bye for now. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now. Work hard and be nice.